So here what we're going to do is we're going to use the basic properties of logarithms that we saw over here. We're going to use these to rewrite these logarithmic expressions as a sum or a difference of logarithms. Keep in mind, natural log that's what the ln is, right? This is a logarithm, namely for any x greater than 0. This is the same as log base e of x. Again, this is for any x greater than 0. So this is a logarithm. It's just that e is a special number, remember, which is why instead of writing log base e, we write ln, gets its own function notation, so to say. But anyway, so from here, remember, we have a natural log of a product, right? We have ln of x squared times the square root of 1 minus x, like so. But if we went back to the properties, what we have here is log base a, in this case a is e, of m times n. That's log base a of m plus log base a of n. So using that, this actually is going to become, this actually becomes ln of x squared. Remember, this is a logarithm, so we can use those properties, plus ln of the square root of 1 minus x. Now, are we done? Well, not quite. We can actually go a step further. For one, let me just rewrite this. Ln of x squared. If you have the square root, that's the same as raising it to the 1/2. So we really have this. Like so. But then, going back to right here. This property here, the exponent is going to come down in front. That's really what we're going to use here. We're actually assuming, even though I didn't write it, that x is such that x is positive and 1 minus x is positive. That's implicitly assumed. But basically, using that property, these exponents can come down in front. So we're going to have 2 times ln of x plus 1 over 2 times ln of 1 minus x. So if I could circle that, wait, that's not going to work. See if I can try again. So basically, we get this. Now, for this one here, we have a quotient. Now, if we went back to the properties there, what we have is this quotient becomes a difference. The quotient becomes a difference. So going here, we're gonna rewrite this. This is going to become ln of the top minus ln. Remember, ln is natural log of the bottom. Now, we can use the same property that we used up here. The exponent can come down in front. So that's what we're going to do now. So this will become 5 times ln of x minus ln of x squared plus 1. Notice this exponent cannot come down in front because you have ln of x squared plus 1. So basically, because we have a plus 1 here, this exponent cannot come down in front. So our answer is just this. Okay? And what we can also do here is we can actually go the other way and actually rewrite this difference as a single logarithm. Okay, so let's do that. So essentially, using the property we used above backwards, this is going to become log base 2 of x plus 1 raised to the 1/2, okay, minus, now the 5 is going to come up, so we have log base 2 of x cubed raised to the 5th. Now, we can actually use, now here we can actually use the laws of logarithms and rewrite that like so. The first term raised to the 1/2, that's the square root, as you can see, minus log base 2 of x to the 3 times 5, which is 15. Now, just like we saw a minute ago, subtraction, we can actually get to division. If we went back, we have this property we can use again. Log of a quotient is the difference of logs. So using this property, we have this difference becomes log base 2 of square root of x plus 1 over x to the 15th, like so.